Hi, going to look at increasing and decreasing functions and using the first derivative test. This is so important for calculus, okay? This is really hitting the heart of the class. Okay, you're going to have multiple AP questions about this, and you're going to be happy when they're there, okay? After you get used to these problems, you're going to see major relationships between an equation and its graph and the behaviors of the function. And that's really the idea of what we're going to get across here. Now, let's look at this function. F of x equals x squared plus 8x plus 12. Okay, now you're probably thinking to yourself, I can tell when things are increasing or decreasing. I'll just pull out my calculator and throw it out there, and I'll just say, oh, okay, it's going down, and now it's going up. Well, yeah, you're right, okay? But the problem is going to turn into is that you're not going to be allowed to use your graphing calculator, okay? There's many calculus questions like this where they just assume you can find the behaviors of the graph without graphing it, okay? And so that's really the heart of this. So what we need to do is pay attention to this function, realize kind of generally what we know about it, and then figure out from there. So like we know this thing's quadratic, okay? That's a good thing to remember. It's a U-shape. Okay, and that's a good thing to remember. And then also that it's continuous. Okay, so this is continuous. That's nice to remember too, which means it's going to be differentiable everywhere. Or actually not because of that. So we know that this is a continuous and differentiable function, hopefully by just looking at it. There's no weird piecewise things. There's no jumps. There's no holes in the graph. No discontinuities. No asymptotes. Nothing crazy happening. This is a nice looking function. Okay, and because of that, I can do this first derivative test and find out the behaviors of the graph. Okay, now some of this looks familiar because you've done these with the extreme value theorem questions. So what we're going to do is we're just going to take the derivative, f prime of x, and we're going to say, okay, well that's 2x plus 8. Okay, so 2x plus 8, that is a, there's a derivative. And what we're going to do is we're going to set that equal to 0, okay? We can set the derivative equal to anything, like 5 or 10 or -3, -1/2. But a lot of times in calc, we focus where the derivative's equal to 0, because that's going to tell us when we have minimums or maximums or a potential inflection point. Something's happening when the derivative equals 0. Things are changing there, okay? And so what we're going to do in this instance, we're going to solve for x. So when you subtract 8, you get -8 equals 2x, and so x equals -4. Now, x equals -4 is called a critical value. Critical value meaning that it's a potential minimum or maximum. Something interesting is happening here. He is critical to understand the question. So I have the critical value of -4. And so what I want to know is what's happening prior to this function, prior to x equals -4, and what's happening after x equals -4. And because that's going to tell me a lot of what's going on. And so that's the idea of a first derivative test. I've done the first derivative, I found the value, and now I'm going to do a test. Well, you need to have some intervals. And so we want to know what's happening. Hey, what's happening before x equals -4? So we usually write it as -infinity less than x less than -4. So all the values prior to -4, we know what's happening at -4. The slope of the tangent line is 0. But what's happening after that? Okay? And so we're going to look at these two intervals right here. What's happening before, what's happening afterward? And so what I want to do is I just want to think of a value that exists before 4 and after, or before -4 and after -4. So we call that a test value. This is something you're going to make up. Just make sure it's in the interval. Don't go with anything too crazy. I'm going to put in -5. I'm going to put in 0 over here. That's always nice to work with. And so those are my two test values. And then I'm going to ask myself, hey, what's the sign of my derivative? Okay, what's the sign of f prime at the test values? Okay. And after we do that, we'll draw a conclusion. Okay, so we're going to conclude here. So we're going to look at this and say, okay, x equals -5. If I put that into my first derivative, notice I'm interested in what's happening here, okay, at my derivative. F of -5, or f prime of -5 is 2 times negative 5 plus 8. And so I get negative 10 plus 8, I get negative 2. So really all I'm interested in is that it's negative. Likewise, I'm going to put in 0. Now, I'll tell you, you're very likely going to get a positive value here. We're expecting that. If we don't, this is kind of a weird question. So you want to see a negative and a positive. So if I put 0 in there, I get 2 times 0 plus 8, and that, you know that equals 8, and that's a positive value. So what do we conclude? Well, if you have negative derivative values, so this interval contains values that when I plug into my derivative, I get negative. That means that this is a decreasing function, okay, at this location. Then it hits x equals negative 4, and it kind of hits 0, and then it starts increasing. I get positive slopes of tangent lines. And so I go from a decreasing function to an increasing function. So what's that say about x equals negative 4? It says that x equals negative 4 is a minimum. So without having to graph it, we know that we have a minimum right here because we got a function that's decreasing until we get to x equals negative 4. And then it starts increasing again after negative 4. And so that tells me a lot of what's going on here. I'll do a few more examples of these in later videos, but this is really hitting the heart of what a first derivative test can tell us.